Graphing linear inequalities in two variables. Hello everybody. If you do not already have it, make sure that you have a new window, not just tab, but window, pulled up next to your math window for your core focus that has your Desmos calculator. We will definitely be needing that today as we do linear inequalities in two variables. Last time we did linear inequalities in one variable, we reviewed greater than, less than, greater than or equal to, less than or equal to. We did a number line, filled in circle, not filled in circle. We learned about SAD-me and we did some algebra. Today, we're going to simply just be matching up graphs to equations. And our Desmos calculator is going to be very, very helpful for us. So right off the bat, I'm going to use number one. Notice there are 7 problems today. You can see this over here. I'm going to use number one as like some notes generally to help us with each of our problems today. So we're going to have a matching problem. So if you scroll down, a lot of times this really frustrates students because it looks so weird. You're like, oh, there's all these graphs in a row. Where are the equations? Well, stay with me. Take a breath. This simply is just the same sort of equation, in this case 2x plus 6. Notice the only difference is the inequality that changes. The first one's less than, the second one's greater than or equal to, the third one's less than or equal to, and the last one's greater than. So on the right, I could just type in my first equation. Y is less than 2x plus 6. Notice as I type this in, the graph changes until it's accurately reflected. And you will see that what I have in this red graph is a dotted line shaded below. And just like always, I can click on any point, especially like the y-intercept, and see it touches at 0, 6. So I want to match up the dotted line shaded below for less than. You'll also notice up here in this little picture that the circle has a dotted line already. And it's a little tough to tell because it's 2 different shades of red, but it's shaded below. So for me, that's this last one. That's graph D. All right. Then I can replace this with a greater than sign. And you'll notice a greater than sign now is a dotted line shaded above. And so I can find, all right, on the left side, where's my dotted line shaded above? Oh, it's A. So I'm going to find on my graph, that is, oh, I screwed up on this already, didn't I? So my less than was graph D. My greater than is graph A. Okay. So remember how when we did the last assignment, we had a solid line when it was a filled in circle, that was equal to? Well, in one dimension, that's true. But in 2 dimensions, check this out. Remember, we could press this button right here. See where I'm pointing? This keyboard at the bottom? It pulls up all of these extra buttons. And I want to do the greater than or equal to button. You can notice them all down here, all clumped together. So greater than or equal to, we end up having a solid line shaded above. All right, so notice that when the solid line is there, the solid line is also here. And that matches graph, looks like for me, B. They're going to be in different orders for you, so don't just copy mine. Make sure you're matching up your graphs, but just do it the same way. And finally, I can see that process of elimination, this is going to be C, but let's just make sure. So less than or equal to is a solid line shaded below. And that should match. Yep, C is in fact that in green. So I can just mark a C. All right, so that reviews all the types of graphs we have. Dotted shaded below, dotted shaded above, solid shaded below, and solid shaded above. Number 2 now, I could type in this equation. Y is less than negative 1/4 x. Oop, I need the x to be on the outside. Plus 3. And right off the bat, I can notice some things about this graph. It's going to be dotted shaded below because of the less than. It's going to have a slope of negative 1/4 because that's what the slope is. So it's got a negative direction, so a downhill skier from left to right, and then it goes up 1/4, up 1/4, and then it has a y-intercept of 3. And again, I could just click on this point and see, yep, 0, 3 is the y-intercept. So I need to find the one over on the left. This one is close, but it's going the wrong direction. The second one, yep, that looks right. Up 1, let's check this. Up 1/3, yep. The next one has a y-intercept of -3. Solid line, not even close to the same slope. Solid line. It's got to be the one I chose. All right, now you can just hit pause at this point and just try the rest of them if you want to on your own, or if you want one more example. Let me show you this one. So now I have a greater than or equal to, which means it's going to be a solid line because it's got the equal to underneath, and it's going to be shaded above the line again because it's that greater than, and then it's going to have a steeper slope because now it's, instead of having a slope of 1/4, it's going to have a slope of 4. Watch it change. Boom, that's steep. If you ski down that one, you are going to get hurt. Okay, wow, that blue one right off the bat looks right. It's crossing at 3. It's up 1, 2, 3, 4 over 1. Yep, I bet that's right. Let's make sure it's none of the other ones. Too flat of a slope. Ooh, this one's close. What's this one? Interesting. 1, 2, 3, 4, 1. Ooh. Oh, look at me. Okay, so here's another mistake. It's early in the morning here. So notice how this is shaded below. That's bad. I want shaded above. So it is that one in pink. And the pink's really close to the red. This one's dotted. This one's not close to the same slope. This one's underneath as well. All right. Getting some warm-up problems done for myself today. Let's roll with it and try this next one. Less than -2 over 5x minus 4. All right, dotted line shaded below because it's a less than. It's got a negative slope, so it's going up and to the left with a y-intercept of -4. All right, that first one looks really close. That one's above. That one's the wrong direction. This one's wrong direction and solid and shaded above. That's as wrong as you can get. Solid line, solid line. It's got to be the one I chose. A lot of times when I teach this, you just sort of look at the graph and the equation, and you don't even need a calculator. Because watch, like the next one I can look at, and I could say, okay, this is a dotted line shaded below, and it's a positive slope crossing at 2. So I'm just going to find one that's a solid or a dotted line shaded below with a positive slope. So that's a negative slope, even though it's dotted. Solid line, solid line. Here we go. Dotted line shaded below, crossing at 2. Does it have a slope of 4? Let's check. Up 4, 1, 2, 3, 4 over 1. Yep. So it's going to be that one. I don't even need to use my calculator. And I'm going to do the rest just like that. It also helps me, I think, make fewer mistakes because I'm using more brain activity and less just trying to like match up calculator interpretations. So for these last two, I'm just going to do that. All right, 6 is a greater than, so that's a dotted line shaded above with a y-intercept at -5 and a negative slope, meaning it's going to cross like this at -5. This is a positive slope underneath at 5, so that ain't good. This is a negative slope crossing at -5, okay, but it's underneath. Nope, I want greater than. This is a negative slope crossing at -5. It's greater than. Okay, this could be it. Let's check the slope. Is it up 1 over 3? Yep. Boom, got it. This one's solid below, solid above. Dotted below, but way up at +5 instead of -5. Nope, nope, nope. No, I'm right. Move on. Good day, sir, ma'am. All right, last one. Greater than. So it's going to be a dotted line shaded above. That's a dotted line shaded below. That's a solid line. That's a solid line. That's a dotted below. That's a dotted below. Wow, look, there's only one option that's even a dotted shaded above. That's being smarter than the problem. Why would I waste time with anything else, including plugging it into a calculator, when I could just simply check the one that makes sense for the inequality, and then I automatically got my answer. You'll notice I got better with time, also better with just trying it out more on my own, because that's what makes sense a lot of times with these graphs. All right, as always, I hope this found you safe, happy, healthy, and well. Best wishes with the rest of your day. It was an honor and a pleasure to teach you today.